So all of you, in front of you is a question on from Econometrics directly, that is application of OLS, right? So let's just have a look at the question. So this is again from the Indian Economic Service question series. So here you are asked to obtain the regression results, okay, regression results of 20 pairs of observation on X and Y, and the following data is given, right? Now, regression results means what are the different results that we have to obtain. So basically, the first one is you have to obtain the regression line by estimating the parameters. All right, that is alpha hat and beta hat. After you have calculated alpha hat and beta hat, the second one is to calculate the standard error of alpha hat and beta hat. And finally, the last one is, once you have calculated this, you have to build the confidence interval of alpha hat and beta hat. After that, you have to test it whether the null hypothesis to be accepted or not. So that is our fourth step, that is testing of hypothesis. So these are the steps that we are going to calculate using the data that is in front of you. So let us quickly write down the data that we have. We are given 20 pairs of observations. So that means n is equals to 20. So n is equals to 20. What else is given? We are given summation xi is equals to 228. So from these two, we can quickly find out x bar, that is 228 by 20. So if we simplify, what do we get? We get 114 by 10. So the answer is x bar is equals to 11.4. Let us keep it with the highlight so that when we will require it, we can easily use it, right? Next, what is given is summation yi. How much is summation yi given in the question? Let's figure out. So it's 3121. So that is 3121. So then again, we can calculate y bar is equal to 3121 by 20. So if we calculate, how much do we get? So y bar is equals to, so let us just simplify it, right? So if you simplify it, we get 1 is 2, 2 5s are 10, 2 6 are 12, 0.5 by 10. So that is 15.65 is our y bar. Right. Now, what is the first step here? The first step here is that we have to calculate the following. That is regression line. So regression line, let's write on the regression line first, that here two variable, one independent and one dependent. So this is just simple regression equation. So our simple regression equation is simple regression equation. Simple regression equation is yi. Simple regression equation, let's say the estimated one, right? We will write down the estimated. That is yi hat is equals to alpha hat plus beta hat into xi. That is our estimated regression equation. Now, so we have to find out this regression equation. So for that, we need alpha hat and beta hat. So we know that alpha hat and beta hat here can be find out by OLS method. What is OLS method? That is error minimization, or the least square method. So what is the meaning of this method? How to calculate it? So we know that for this general equation by OLS method, that is our error. Error is what? The error is basically the mistake, right? Whatever the actual value of yi is and whatever the estimated value of that yi is. So the error of estimation is EI. So I can write down EI is equals to YI hat minus YI. So YI is the actual value and YI hat is the estimated value. So EI is equals to basically what we get is alpha hat plus beta hat xi minus yi, right? Now we take square and then ultimately we will take summation of this, and then finally after minimization we obtain alpha hat is equals to y bar minus beta hat x bar. Okay, and so we need beta hat first in order to calculate the alpha hat. So beta hat, what is it? It is summation xi yi by summation xi square. So these are all small xi yi, where small xi is equals to what? Capital Xi minus x bar, and small yi is equals to capital Yi minus capital Y bar. So now let us calculate the values of alpha hat using this formula that we will get using the OLS method here. So for that, first let us calculate beta hat. So we have summation xi yi. Let's go up and check the value. Right. So summation xi yi, small summation xi yi here. So the value is 3347.60. 3347.60. Let's write down. Divided by, next is summation xi square. Yes, that is 604.80. 604.80. Okay, this one is 3347.60, right? And summation xi square is, as just mentioned up from the data, it is 604.80. So 604.80, right? So this is beta hat. So if we calculate it, we will get value approximately 5.05. Okay, so this becomes our beta hat value. Now we will use these values in the alpha hat and calculate the value of alpha hat. So therefore alpha hat, which is equals to y bar minus beta hat x bar, is equals to, so how much is y bar? We have calculated here, that is 156.05. let's write down, that is 156.05 minus, how much is beta hat? Here we have got 5.05, and how much was x bar? I remember it's 11.4. So let us calculate, and if we calculate this, we will get the answer as 9.8 something. So this is the approximate value. So we have got the value of alpha hat and beta hat using the OLS method. Now since I have the value of alpha hat and beta hat, so I can easily write down the estimated regression equation. So therefore the estimated regression equation, that is y hat is equals to alpha hat plus beta hat x, is equals to y hat is equals to 92.8 plus 5.05x. So this is the estimated regression line that we have derived from all the data given. So this was the first part. Now the second part is about to calculate the standard error of alpha hat and beta hat, right? So the variance of alpha hat, the formula of variance of alpha hat is equals to how much? We know that it is sigma square summation capital xi square divided by n into summation small xi square. Okay, and variance of okay, let's not write it here, let me write it down here. So variance of beta hat is equals to again sigma square by summation small xi square. Now in this case we know that sigma square is unknown, so we cannot use sigma square because we have to again find out the value, that is the testing of hypothesis. So for that I'm going to use the unbiased estimator, right? So the unbiased estimator here is going to be replace sigma star with sigma star square, which is unbiased estimator, right? Now what is the formula for sigma dash square? Sigma dash square is equals to summation ei square divided by n minus 2. So that is the formula for sigma dash square, that is the unbiased estimator, right? Now, so we have to calculate it. Let us put the value of summation ei square here. So that is, okay, now before that, let's write down variance of alpha hat. So our variance of alpha hat becomes sigma star square times summation capital xi square divided by summation small xi square with small n. And our variance of beta hat can now be written as sigma star square by summation small xi square. Perfect. Now let us calculate the value. So for which I need first the value of sigma star square. So sigma star square is summation ei square whole divided by n minus 2. So in place of ei square, what I'm going to write is summation summation star square is equals to summation small yi square minus beta hat summation small xi square, okay, divided by, we have our n minus 2. Now if we look at these, we have small summation yi square, we have beta hat square, and we also have summation xi square. So let us just put the values here. So what is summation yi square? Let's go up and find out the data. Yes, so the value is 19837. Okay, 19837. So let us just write down the values here. This is equals to 19837 minus beta hat square. We have just got the values. We have got the value of beta hat as 5.05. So if we square it approximately, we get 554. Okay. Into summation xi square also we have got. So from there we have 604.8. So these are the values that we have got from calculation as well as the data. Divided by how many n we have? So we have 20 observations. So this is 20 minus 2. So let's directly write down it as 18. Right? So after calculating, here we get sigma star square. That is the unbiased estimate. Sigma star square is equals to, so if we solve it, we will get something around 70.8 approximately. Okay. So this is the value of sigma star square. So we can put this value in the formula for variance of alpha hat and beta hat, and we can calculate the value. So variance of alpha hat, which we have written as sigma star square into summation capital xi square by n into summation small xi square is equals to 70.82 into, what is the value of capital summation xi square? So from data we have built as 3204 divided by n is 20 times, again small summation xi square is 604.8. So if we calculate it variance of alpha hat is equals to 18.75. Okay, so let us highlight it because later on we will need the standard error values as well. So this is variance of alpha. Now by the formula of variance of beta hat, we have sigma star square by summation small xi square, that is equals to 70.82 divided by 604.8. So if we calculate it, we will get variance of beta hat is equal to 0.117. So this becomes our answer for the variance of the OLS estimates, that is alpha hat and beta hat. Okay, so after we have got it, next we are going to find out our confidence interval for alpha hat and beta. The construction of confidence interval here for alpha hat and beta hat at 95%. Okay, so first let us write down what we know about the confidence interval of alpha hat. So we know that basically alpha hat, the confidence interval for it is basically alpha hat minus t alpha by 2 comma n minus 1, that is the degree of freedom, into standard error of alpha hat, right? This is less than equals to, so what are we trying to find out here? So we are going to find out the value of alpha, that alpha whether lies between this or not. So this is the lower value and the upper value is less than equals to alpha hat plus t alpha by 2 n minus 1 standard error of alpha hat. Now let us put the values. So for that I need the standard error of alpha hat because there we have got the variance of alpha hat. So the standard error of alpha hat is going to be 4.33. Okay, so we will use this value here. So let's put the value. So alpha hat we have calculated using the OLS method, that is 92.8 minus, okay, now t alpha by 2. So since this is at 95%, so the level of significance is 5%, right? So because this is a two-tailed test that I'm going to do, so I'm going to take 5%, that is 0.05 by 2. So t 0.025 comma n minus 1 is 19 degree of freedom. And SE of alpha just now we have got is 4.33. So this is less than equals to alpha, again less than equals to 92.8 plus t value of 0.025 comma 19 degree of freedom into 4.33. Now what is the value of t 0.025 at 19 degree of freedom? So let us just write it down. I will use a different color. So that is t 0.025 at 19 degree of freedom is equal to 2.01. Okay, so the value is 101, right? So I'm going to use this value and put it here. So let us calculate now. So 92.8 minus 2.101 into 4.33 less than equals to alpha less than equals to 92.8 plus again 2.101 into 4.33. Now all we need to do is just calculate, and after calculation we will get this as 83.79 less than equals to alpha less than equals to. So the variance of alpha hat, the formula of variance of alpha hat is equals to how much? We know that it is sigma square summation capital xi square divided by n into summation small xi square. Okay, and variance of okay, let's not write it here, let me write it down here. So variance of beta hat is equals to again sigma square by summation small xi square. Now in this case we know that sigma square is unknown, so we cannot use sigma square because we have to again find out the value, that is the testing of hypothesis. So for that I'm going to use the unbiased estimator, right? So the unbiased estimator here is going to be replace sigma star with sigma star square, which is unbiased estimator, right? Now what is the formula for sigma dash square? Sigma dash square is equals to summation ei square divided by n minus 2. So that is the formula for sigma dash square, that is the unbiased estimator, right? Now, so we have to calculate it. Let us put the value of summation ei square here. So that is, okay, now before that, let's write down variance of alpha hat. So our variance of alpha hat becomes sigma star square times summation capital xi square divided by summation small xi square with small n. And our variance of beta hat can now be written as sigma star square by summation small xi square. Perfect. Now let us calculate the value. So for which I need first the value of sigma star square. So sigma star square is summation ei square whole divided by n minus 2. So in place of ei square, what I'm going to write is summation summation star square is equals to summation small yi square minus beta hat summation small xi square, okay, divided by, we have our n minus 2. Now if we look at these, we have small summation yi square, we have beta hat square, and we also have summation xi square. So let us just put the values here. So what is summation yi square? Let's go up and find out the data. Yes, so the value is 19837. Okay, 19837. So let us just write down the values here. This is equals to 19837 minus beta hat square. We have just got the values. We have got the value of beta hat as 5.05. So if we square it approximately, we get 554. Okay. Into summation xi square also we have got. So from there we have 604.8. So these are the values that we have got from calculation as well as the data. Divided by how many n we have? So we have 20 observations. So this is 20 minus 2. So let's directly write down it as 18. Right? So after calculating, here we get sigma star square. That is the unbiased estimate. Sigma star square is equals to, so if we solve it, we will get something around 70.8 approximately. Okay. So this is the value of sigma star square. So we can put this value in the formula for variance of alpha hat and beta hat, and we can calculate the value. So variance of alpha hat, which we have written as sigma star square into summation capital xi square by n into summation small xi square is equals to 70.82 into, what is the value of capital summation xi square? So from data we have built as 3204 divided by n is 20 times, again small summation xi square is 604.8. So if we calculate it So this is variance of alpha. Now by the formula of variance of beta hat, we have sigma star square by summation small xi square, that is equals to 70.82 divided by 604.8. So if we calculate it, we will get variance of beta hat is equal to 0.117. So this becomes our answer for the variance of the OLS estimates, that is alpha hat and beta hat. Okay, so after we have got it, next we are going to find out our confidence interval for alpha hat and beta. So less than equals to 101.99. So this becomes the, so we have constructed the confidence interval for alpha. What does this confidence interval mean? This is the acceptance region, right? So if the value of alpha lies between this, then the value will be accepted. Otherwise, we have to reject it. So that is what we are going to test in the testing of hypothesis. But before that, we have to also find out the interval for beta. So again, for beta, the confidence interval for beta, let us write down. So it will be what? Beta hat minus t 0.025, 19, standard error of beta hat. Less than equals to beta, less than equals to again beta hat plus t 0.025, 19 and standard error of beta hat. So again we need standard error of beta hat. So just we will go up and calculate the standard error of beta hat. So we have variance of beta hat. So standard error of beta hat from here, we will get it as 0.34. So we will use this value directly here. So we get, so beta hat is 5.05 approximately, minus, this is the value of 2.101, into standard error of beta is how much? Standard error of beta hat we just now saw is 0.34. Less than equals to beta, less than equals to again 5.05 into, so plus 2.101 into 0.34. So after calculating, we will get the lower and the upper limit, that is the confidence interval. So which is, if we calculate this left side, we will get 4.83, and on the right side we will get 6.25. So that means this is our required acceptance region for beta. So now we have to test the value of beta, whether the value of beta is in the acceptance region or not. So for that we are going to do the last step of this method, of this problem, that is testing of hypothesis. So what are we going to test here? We are going to test whether there is any dependency between the two variables, that is the x and y, that is the independent and the dependent variable. So our null hypothesis is there is no dependence between x and y, that means beta is equals to 0. Versus alternative hypothesis, that is there is dependency, so beta cannot be equals to 0. We have to see whether there is dependency or not, depending on the value of test statistics and then whatever we are going to get. Now the test statistics here is our t statistics, right, for this one. So the tests, let us calculate the test statistics. So here the test statistics at beta is equals to 0. Let's write down the test statistics at null hypothesis beta is equals to 0 is t is equals to beta hat by standard error of beta hat. This is the formula. So after calculating, what do we get? What is beta hat? Beta hat is, let's say, 5.05 and the standard error of beta hat is 0.34. So approximately the value is, the test statistics value is 16.9 approximately. Okay, 16.29 approximately. Now this is the calculated t. I have to find out the tabulated t. So what is tabulated t? We have already got tabulated t, that is tabulated t is 0 at 0.025, 19 degree of freedom, that is equal to 2.101. So clearly here the calculated t is greater than, therefore the calculated t value is greater than the tabulated t value, or 16.29 is greater than 2.101. Therefore, null hypothesis is rejected. So what is the meaning? X and Y. So there exists dependency between X and Y variable. And with that is our answer and the full regression results that was needed. And